Welcome to my talk on Facebook video delivery. My name is Colin Smith, and I'm an iOS engineer. Let's dive straight in. Let's start off with why video is so important for not just Meta's growth and the 3 billion users on the platform, but the world at large. Did you know that 92% of internet users worldwide watch an average of 19 hours a week of videos? I don't know about you, but I personally find myself watching meme videos pretty much daily. On top of just the sheer amount of time people spend watching videos, videos on social media are starting to replace search engines. In 2023, 36% of Gen Z use social media video to search for brands instead of search engines. For example, if someone from Gen Z is interested in a hot new restaurant in New York City, where I live, they'll go to Instagram to learn more instead of a search engine. Some of the competition in the space is another sign of video's importance, including YouTube, Netflix, Snapchat, TikTok, and more. Some of the largest companies in the world have significant investments in video. So now that we have some context on video's importance, let's dive into the agenda. First, I will go into some of Facebook's previous and ongoing work to unify our video experience on Facebook app. I'll cover some of the motivations, challenges, and different phases of the project. Then I'll be diving deep into the key mechanisms of our mobile delivery stack and how it integrates with our AI-powered ranking systems. After that, I'll explain how our key delivery layers work together to serve engaging content using some advanced features. And I'll end on some of the big takeaways of the talk. So let's dive into video unification. Video unification has been integral in evolving our product and its infrastructure. It has also enabled great advancements in our AI-powered recommendation systems, which I'll refer to as ranking as well. This has been a huge effort starting 2 years ago with work continuing today. So why are we investing in unification? Well, Facebook is about opening people's worlds in big and small ways through social discovery tools, and video is very, very important for that. However, before video unification, Facebook's video products were fragmented and disconnected. This made it hard for people to find the best content on the internet. The videos people enjoy in Facebook's Watch tab didn't influence which reels they were shown, and vice versa. Video unification is the plan to address the previously stated issues by merging all video products, Reels, Watch, and Live, into a unified, simplified experience. Our new unified product systems are helping people effortlessly enjoy the best content on the internet. Creators will be able to reach a broad and relevant community while monetizing both short form and long form content effortlessly. And for Facebook, unification will improve our agility to respond to dynamically changing video market by reducing duplication of work across formats. So let's talk about why this project is complex. First off, we have billions of users on the product, and shifting their experience takes time. Another reason is we had two separate systems before, Reels and Watch. We had to preserve their key features while merging them into a single stack and product. This required auditing hundreds of features and porting them. We also had to deal with tens of thousands of lines of code per infrastructure layer, mobile, server, and ranking. Another factor was that we had to compete with the old system as engineers continued to improve it. Deciding the cut point for pushing engineers to the new unified system was a difficult balancing act. And finally, we had to do all of the above while maintaining engagement and performance metrics in order to ensure our high quality bar. Next, I want to dive into an example of the architecture before. There were two completely separate stacks between Watch and Reels across all the main layers of the product, mobile, server, and ranking. This meant if we wanted to make a change for all video surfaces, we would have to make changes in many different places. This led to many hours of work implementing, testing, and maintaining them long term. This slowed us down tremendously and made it difficult to work on advanced features in our product. As you can see after, we were able to condense our layers into a single infrastructure and product experience. This new system addresses all of the issues of the bifurcated infrastructure I mentioned in the previous slide. We are now able to implement and iterate much more quickly. Next, I'll dive into the order of operations we took for unifying. Our first effort to unify came from a project to turn Watch directly into an immersive surface, like Reels. It struggled due to lack of cross-discipline teams, since it was mostly being driven as a product change. Through this experience, we understood that infrastructure, delivery, performance, and ranking would all play a key role in making our unified video experience possible. This learning led us to unify our technical stacks, starting with iOS, Android, and server. This unified tech stack supported both Watch and Reels, where previously these two products had separate stacks. Next, we leveraged our new unified tech stack by migrating the Watch chaining experience to match an immersive Reels product experience. This project shipped earlier this year. We then finished our infrastructure migration by unifying our ranking layers. This shipped in August. We are currently in the last step of migrating our product surfaces by shifting Watch tab to an immersive experience. Let's cover some of the challenges of pulling off a large unification project on the mobile client. One of the major difficulties was preserving logging. It was key that we preserved logging capabilities of both systems during our unification efforts. This was incredibly time-consuming given the sheer number of things we log and the sensitivity of the logging. Another challenge was ensuring the unified stack used the latest and greatest tech. The newer Reel stack was using our most advanced mobile feed delivery technology we call client-side ranking. We had to integrate this tech into the new unified stack to meet the quality bar necessary for launch. Typically, integrating this technology into a new stack can take anywhere from 6 months to a year. We had to do it in 3 months due to the timeline we were facing. The next challenge was creating a data model that could work for both products. The two data models were quite different in structure and what fields they had. We had to unify them into a single model that would work for both systems. Lastly, performance and reliability is always key in launching a major change, and that was absolutely the case in this project as well. We saw elevated crash rates and slow load times, and we had to dive deep to fix them. So now that I've covered video unification, let's dive into how the new unified delivery stack works in detail. Mobile delivery is all about balance. All of these pieces I'm going to cover have trade-offs against each other. Let's dive into some of the key terms here. Knowing these terms will be important in understanding later portions of the talk. Let's start with our fetching mechanisms. First off, we have the head load, which is the top of feed request. It's the first request we fire when the user lands on the surface. And it's important because it plays a key role in whether the user will stay on the surface. Tail loads are the subsequent video feed requests following the head load, as the user scrolls down the feed. A prefetch is our off-surface fetch. It allows us to fetch content before the surface is visible. Caching covers our ability to write our previously fetched network content to disk and restore it for use in later viewing sessions. This allows us to smooth over scenarios where the user might be facing poor network conditions. Caching leads to better performance with the cost of content freshness. Vending behavior determines how much content we insert into the UI as the user scrolls through the feed. Inserting content too eagerly could lead to showing repetitive or less engaging content. but we may see performance hits if we don't insert content eagerly enough. Capacity is the cost we pay for running our video feed server infrastructure. If we make more requests, we generally drive this cost up. But more requests generally lead to fresher content, so there is a trade-off. Performance covers how quickly our experiences load. This applies to the initial surface loading as well as subsequent video fetches as the user scrolls through the feed. All of the above elements intertwine and intermingle. Fine-tuning each piece is critical in providing the best experience for our users. On to freshness and responsiveness. These two terms help us describe and measure the likelihood of our AI-powered ranking systems serving a user relevant content. We measure freshness from the time a video was generated by ranking to when a video was served to the user. We generally consider fresher content to be better since it's operating on more recent and relevant signals. Responsiveness is how consistently our end-to-end infrastructure delivers fresh content. Now that we've covered some key terms, let's go into the principles we use at Facebook Video to guide our trade-off decisions. We created our principles to ensure that everything we do as a team ladders up to a greater but simple purpose. Let's start with our first principle. We always want to prioritize vending network content because it is fresher, which we've covered is better in the previous slide. For the next principle, we defer to the ordering of content to ranking because ranking has more information available and powerful tools for determining the optimal order of content. Let's go to the next principle. We delay vending in order to give the network as much time as possible to return a fresh network response. There is a trade-off between performance and prioritizing network, so we generally try to tune this through A/B tests. Lastly, when the user gives a clear indication in the app that they want content, such as a swipe or a tap action, we break all of our other principles and vend whatever is available. If the user is giving clear signal they want content, we do whatever we can to deliver immediately. Now that we have covered some key terms, as well as principles, let's go into some more detailed scenarios. I'll be covering our tab use case for these examples. For our tab, sometime after the app starts, we kick off our prefetch request. When the request returns, we vend 2 pieces of network content to our UI in the background. We call this pre-rendering. This ensures that there is content quickly available when the user goes to the tab. Once we land on the surface, we kick off our headload request. If our prefetch is still in flight, we will kick off our headload in parallel. The request that finishes first will be shown at the top position. If they return around the same time, we defer to what we call the server sort key, which is the time that the content was generated in our ranking layer. This goes back to the first principle I mentioned before. So in this case, we would prioritize headload content over prefetched content, since it was generated later and is therefore fresher. Tailload is generally simpler. The main complexity is when do we kick it off? We generally will trigger it based on how much network content we have in our in-memory pool. On the left side, you can see our UI list, with the current position being position 6. On the right side is our in-memory pool, which holds all of the videos that are ready to be vended to the UI list on the right. These videos can be from network or from cache. For tailload, our minimum required number of network fetch videos in the pool is 3 videos. If we have this number of videos in our pool, we don't fire the request. If we don't have this number of videos, we do fire the request. We reevaluate this condition each time a user swipes to a new position. In this example, if we scrolled from position 6 to position 7, since there are only 2 network videos in our pool, the network tail load request would fire. The one thing that overrides all of our principles is responding to user interaction. We give the network some time to make its round trip before vending cache. The one thing that leads to instant cache vending is if the user attempts to swipe to the next video. When we detect this, we immediately vend cache content, since the user is giving clear signal they want content now. In this example, the user is at the top blue video in the UI on the left side of the slide. They are attempting to swipe to the next video, which is loading. We have detected that swipe, and we will now vend our orange cache video to the loading position. And we would have waited longer for another network video if the user had not swiped. Now I want to speak about some new and advanced concepts and features we have been working on. So how have we taken advantage of this simpler system and cross-layer communication to reach our goal of serving the best content? One thing we have done is created metrics to ensure that if network content was available on the client, we prioritized it over cached content. If we failed to serve network content when it was available and instead served cached content, we categorized this as having served regrettable cache. We now have metrics in place as well as monitoring that flags if any A/B test is regressing this metric by serving too much regrettable cache. Regrettable cache is a good starting point, but not quite fine-grained enough to make the best decisions around whether a piece of content is truly fresh or not. The true indicator of freshness is when the content was generated by ranking, not whether it was loaded from cache or network. This is merely a decent proxy. There are cases where a video was loaded from cache, but is actually quite fresh, maybe only generated an hour ago. So how are we tackling this? We are creating a new metric that measures when the video was generated by ranking and compares it to the current time. We call this video age. This is a better indication of freshness. Another key feature that the unified system makes possible is end-to-end signal collection and utilization. Signal collection is the process of collecting user signals, as you can see in the white box labeled signals in this slide. These signals are things such as a like, a share, watch time on a video, and more. We then send those signals from mobile, represented in purple, all the way to our AI-powered ranking layer with our next video request. The green box in this slide is our AI-powered ranking layer. It will use these signals to modify its video candidate generation to ensure the user gets relevant content based on what they are interested in viewing in this current session. For example, if you are served a video about cooking and a video about basketball, and you liked and watched the video about basketball for 5 minutes, we would send these signals in our next request so ranking could then generate more videos related to basketball for you. The next and most recent advanced feature I wanted to cover is called dynamic pagination. Previously, our page size was static and actually a different size from mobile to server and server to ranking. This led to inconsistencies and inefficiencies. This slide represents the system before our unification efforts. Before, caching occurred at the server layer, which you can see as the blue box showing 25 cached videos. Ranking also generated a large amount of candidates, represented by the green box. I was a mobile engineer working in this stack, and I had no clue that so many videos were being generated when we made a network request on the client. We were using a lot of capacity by generating 40 videos in the ranking layer and having a much smaller chance of serving the user fresh content that was relevant to them. Each layer was doing what was independently effective in an isolated context, but not as a system. Dynamic pagination decouples page size from the mobile client and server layer and defers the page size to the ranking layer. Whatever amount of videos ranking returns, the server and mobile layers will handle. This is harder than it sounds. Through unification, we unified the page size to 10 across all layers. You can see this illustrated in this slide. This allows for a full ranking pass on each video request. This was necessary as a first step in achieving dynamic pagination. Doing this also increased engagement. The next step was completely decoupling the page size from the mobile and server layers and letting ranking return any number of candidates. We had to tune the mobile and server layers to be able to handle the minimum and maximum number of videos in a page. In our case, 5 on the low end and 20 videos on the high end per page. In this slide, you can see the purple mobile client generically requests videos to the server, represented by a blue box, which then passes that generic request to ranking, represented in green. In the top example, ranking returns 5 videos, and in the bottom example, ranking returns 20 videos. Some users might respond better to smaller page sizes, and other users might respond better to larger page sizes. This allowed us to tune the page size to different users to achieve the best results for both engagement and capacity usage. Smaller page sizes will lead to more capacity usage since we need to make more round-trip requests, while larger page sizes will have the opposite effect. Let's go over some of the key points we covered today. I hope that this talk has driven home the value of a simple and unified system. By having simplified infrastructure end-to-end, we are able to do more complex things more quickly than we ever could have before. The end-to-end stack needs to be focused on a single goal. In our case, freshness balanced by performance. With all layers working in sync towards this outcome, you can push product excellence much further. Even though our unification work has taken a lot of time and effort, we are already seeing big payoffs by being able to ship large projects much faster than we could have before. Lastly, video is always changing. Even in the last 7 years since I've worked at Meta, I've seen so much change. Ensuring your architecture is set up in a way to allow you to be nimble is key to being successful in the video space. And to end this talk, I'd like to proudly announce that we have successfully shipped our Unified Tab experience to the US and Canada. This project has been in development for over a year, with a large team working on it. And with this huge milestone accomplished, we have one last milestone remaining, which is shipping the Unified Tab to the rest of the world. Thank you so much for sticking around, and I hope you enjoyed the talk. Thank you.